What's good, y'all? Welcome to another video. Okay, I think I fixed it this time. It has to. If it's not, bro, I don't know. I don't know if this is new or not because I've never seen this before. But I changed this to my actual mic, which I freaking my stupid ass didn't realize to do. So it should sound a little better. If not, bro, alright, another day of a shitty mic. But either way, let's just keep it going. Day 222, 222. Uh, Files versus network. Files and network connections behave very similarly. That's why we get started by simply reading and writing to files, then updated our code to be a bit more abstract. The getLines function so that it can handle. Files and network connections behave very similarly. That's why we started by simply reading and writing to the files, then updated our code to be a bit more abstract. GetLines channel so that it can handle both. From the perspective of your code, files and networks are both just streams of bytes that you can read from and write to. All of a sudden, goes io.reader and very similar to io.readCloser and io make a lot more sense, right? They're designed to work with any type of stream, with whether it's a file, a network connection, or something else entirely. When you read from a file, you're in control of reading the process. You decide when to read, how to read, when to stop reading. When you pull data you pull data from the file. When you read from a network connection, the data is pushed to you by the remote server. Okay? You don't have to control over when the data arrives, how much arrives, or when it stops arriving. Your code has to be ready to receive it when it comes. The IO reader and IO reader interfaces are useful for reading and writing data to and from network connections and files. So, yeah. Which pushes data to the application's reading from it and resulting the reader to. Is it network connections? Yeah. So.
So you're probably asking yourself, why do we use HTTP and not TCP? Well, it actually is a pretty simple answer. TCP guarantees that your data is in. So you're probably asking yourself, why do we use HTTP and not TCP? Well, it actually is a pretty simple answer. TCP guarantees that your data is in order and complete, that there's no missing packets, that there's not problems. But it doesn't really tell you what the data is. Am I sending you just JSON? Am I sending you some sort of image? What am I actually sending you? HTTP gives you the ability to specify what you are sending. So first off, it also gives you a destination within a server, because just because you're on a port and an IP address doesn't mean it's going to the right place still. So first off, HTTP comes with kind of like your main address, like, hey, I want to go to /cats and I want to get all the images from /cats. Next, it's going to have some basic kind of control things. We call these headers or field lines from the RFC. After that, we're going to have a body if you need a body. Most requests don't come with bodies. Usually it's the response from the server that comes with the body, and the body is usually the data you are requesting. So without HTTP, our TCP data would effectively be meaningless. How do you ever even parse it or come to the conclusion for what I am requesting? And during this whole course, we're going to be talking about HTTP 1.1. But the reality is we're not just talking about HTTP 1.1. RFC 9110 actually contains the semantics for all of HTTP. We're going to be primarily using 9110 and 9112 for implementing HTTP 1.1. And the reason being is that HTTP 1, 2, and 3 semantically are equivalent. It's just simply the implementation across the wire that is different. So in HTTP 1.1, we still send headers, but we send the same headers every time. Potentially you're sending really large cookies, maybe you're sending all those different things that are all the same every single request. With HTTP 2 and 3, there's something called HPAC and QPAC, which allow you to take the same reoccurring headers and actually shrink them down to say a couple bytes. This could be beneficial considering how big some of these headers can get. Now, the shape of any HTTP message is going to be the same whether it's a response or a request. There's just some subtle differences. Effectively, everything is called an HTTP message. Now, an HTTP message, the first line is going to be kind of the declaration. So say on a request, it's going to start off with a big capital letter get. This is going to be a get request. The next thing is going to be the destination. So it could be get cats. And lastly, it's going to be the semantic version of HTTP. So it could be HTTP 1.1. Every single line in the HTTP 1.1 algorithm is separated by a /r/n, which I jokingly refer to as a registered nurse because that's the only way I can remember the ordering of /r then /n. So after the first line, the status line, we then go to the field lines. Now there can be 0 or more field lines. Field lines are headers. Simply it consists of a field name, a colon, and a field value, and then one registered nurse at the end. And how HTTP 1.1 knows it's done is that there's an empty field line. It's just simply one registered nurse and nothing else on the line. After that, it's just the body. Now, you're probably asking yourself, well, how big is the body? There's a couple different strategies. There's chunked transfer, and then there's also content length. You've probably seen content length a few times if you've ever been perusing request and response. The content length will tell you how big the body is in bytes. During the course, I'm going to be referencing the RFCs 9110 and 9112 quite a bit, so if you take a look at those, it's actually pretty helpful, especially 9110. It's a very long document, and it could take quite a few hours to go through, but it would definitely shed a lot of light on why things are the way they are.
Okay. Because plain text is HTTP works because plain text is binary. Because HTTP uses TCP, if HTTP request or response is too big to fit in a single TCP packet, it can be broken up into many packets and reconstructed in the correct order on the other side. TCP guarantees that the data is in order and complete. At the heart of HTTP is the HTTP message, the format that the text in an HTTP request or response must use. From RFC 9112 section, start line, message body. CRLF, written in plain text as, is a carriage return followed by a line feed. It's Microsoft's window and style new line character. I call our register nerds. It helps me remember the order of the characters. Let's break down each part. Start line is like post that. Okay. The request for a request or status for a response line. Okay. Host. 0 or more lines of HTTP headers. These are key value pairs. Okay. Then CRLF, a blank line that separates the headers from the body. Then the message body. The body of the message. This is optional. HTTP requests and responses follow the same format. Due to the contents of each section will differ, we'll get to that. Run your TCP listener program and redirect the output to this. Okay. Boom. Okay. In another shell, send a GET request. Okay. Curl. 420. Wait. Okay. Boom. What? Oh my god. Wait, that's fire. Well, hang because... Yep. Because TCP just listens. It doesn't respond. But you should see the request come in your TCP listener. Whoa. Okay. Boom. We got the GET, the host, the user agent, the accept. Kill both programs. Boom, boom, boom. You should contain. You should. The file should contain. Hold on. Did I? Well, I think it's in my temp, so that's why. Wow. Super beautiful. All right. To be clear, here at the startup, we will build HTTP 1.1. To understand HTTP, it may behoove you to become familiar with RF's request for comment at the moment. There are several keys for HTTP 1.1. RFC 723. Okay, what the fuck? Wait, what? Request for comment. Okay. To understand HTTP, it may behoove you to become familiar with the RFCs. Request for comments. I still don't. What the fuck does this mean? Public is a publication in series from principal technical development and standard setting bodies for the internet. Okay, something like request for comments. Okay. Request for 7231, an active and widely referenced RFC. Easier to read than RFC 7231. Relies on the understanding from. Okay. We will be referring to 9110 and 9112 as they have better separation of information. Verbose, whereas 9112 is more, it's much more to the point. But it makes a lot of assumptions that you need to understand a decent amount of 9110. Which RC will be 1, 1, and 2? 1, 1, and 2. Bro. This is a crazy scientific document. This looks scientific. Okay, HTTP post. You probably already figured this out or knew, but curl is a command line for HTTP requests. Ucat. Yes. Let's try that real quick. Cat temp raw get. Yeah. That's so cool. This is what a raw HTTP message looks like. Specifically, a raw HTTP GET request. A request line get / goodies. Headers, these things, right? And then body, empty. Let's see a raw HTTP post request looks like. Okay, so let's do that. So we will do go run this, and then we will make a post request. Boom. All right, so we got a curl -x -h. The header is gonna be content type application JSON with some body body, and then we're gonna make a post request to /coffee, and then we didn't get no body. We didn't get a body. Oh yeah, it's just showing up in the season, and that's because it doesn't end with a new line. Kill the curl command, and your TCP listener should flush out the. Oh, okay. Oh. Oh no 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 no! Oh, I messed up. Hold on. Let's do it again. Oh no no. Let's do this. This. Wait. So kill my. Okay. Run this. I'll have this. Then I'll have kill this, and it'll flush out this. Kill the curl command. Or kill your curl command and your TCP. What? And kill this. I thought it would show. Is that a bad thing? I don't know why. Yeah, I didn't get this. That's weird. Okay, let me run this again. So let's run my TCP, right? And then let's run my this curl x post that boom, right? And then in another shouldn't send a post request. Again, this time your curl command will hang, but this time you might notice that the body isn't showing up. Yeah. Okay. And then that's because it doesn't end in line. Kill the curl command and your TCP should flush out the rest of the request. Okay, I'm gonna kill this. And then it still doesn't do that. What? Kill your TCP program. Okay, so we have an issue with our this. Is it because it's this? I think it's because I don't print out the last thing. Hold on, let me try one more thing. fmt.print. Yeah, I see. I know why. Because we might error out here, so I should print out the last thing. So fmt print okay, not print. Hold on. I should send the last thing. If curl line then I should, where is it? Channel send the curl line. Yeah. So okay. Let's try this. And then do this. So let's first let me run my this. So run this. Send this. Got that. Kill the curl command. There you go. Kill this. And then that's good. Great debugging skills. Beautiful. Yeah. I forgot that my thing doesn't print out the last thing. My thing doesn't print out the last thing when it errors out. So nice little catch. All right, so we're good with this. Let me see. Is there any more coding sections? No. All right. For today, we're gonna finish up the. Wait, what? Why didn't we get a completion for this? There you go. Okay, we're gonna finish up these and then call it a day. You probably already figured out or knew, but okay, well, whatever. Start line, field line, and message body. Field line, and then message body. Which of the two requests has a non-empty message body? Neither. Wait, what? We have a okay. Which of the two requests in our example has a non-empty? So it has a. Our post has a. Yeah. And then curl. Okay. Which line is not a header? Well, they both have it, right? What does that mean? Oh, which line is not a header? So header is everything except for the message body. Right? Curl user agent. Okay. Well, that's a field line. Forgot. Start line. Wait, isn't this everything the header already? Except, which is not. So get. No, these all of this host. That's fine. User agent. Which line is not a header? Oh, a field line. Oh, which is not a field line. So this. Yeah. All right. Beautiful. So next chapter is request lines. Ooh, beautiful. All right, guys. All right, yeah. We'll do this tomorrow. Anyways, thanks for watching, guys. I'll see you tomorrow. Peace.